Secondary growth. When we think of plant growth, we think of things growing tall and upwards from the meristem. With secondary growth, what we're looking at is we're looking at thickness, and thickness comes from a different set of growth parameters. In secondary growth, what we see is we have got a cambium, and the cambium is basically a sheet meristem. So instead of a little point meristem, you've got a large sheet meristem, and this goes around the outside of the plant. And as the cambium works, it produces cells to the inside, it produces cells to the outside. Cells to the inside become the wood, cells to the outside become the bark. The outer part, therefore, is what we call the bark. And the bark is made up of many different cells, and we call these the periderm and the phylogen. And these particular parts give us things like cork and other light materials that become very interesting. On the inner part, we have the wood. And you can see the wood there, and you say, yes, this is wood, and we all know it looks like wood. And this particular one was actually a branch of a tree that got cut down. And in the wood, you can see it's got two different colors. The outer color is what we call the sapwood, and the sapwood is basically that which is very active in growth and active in transport of nutrition. All of this is xylem, and you see that nice light color to it. The heartwood is wood on the inside that is no longer functional. It has started to acquire a lot of materials in it that are just kind of stored in there. They stop decay, they stop rot and other things like that. It gives you that nice dark color in there that we call the heartwood. So sapwood is on the outside, heartwood is on the inside. This also happens to be something we call reaction wood. What is reaction wood? Think of it like this. When we think of a tree, we think of it growing straight up. And as it grows straight up, it is supposed to have a central spot, which is where it started to grow from. If we look at the central spot on this, that's at the end of this arrow. And you can see that that is not in the center. That's what we call acentric. It's shifted off to the side. And basically this limb was growing outwards. And in order to grow outwards, it started to react and put more material underneath of it than it had on over top of it so that it supports it up better. The distance from the tip of the arrow to the bottom of the wood and the tip of the arrow to the top of the wood are two different things, but they represent the same number of years of growth. So when we look at reaction wood, we're actually seeing something that's a little bit shifted. Another term we use is hardwood versus softwood. Hard versus soft. Now this really has nothing to do with the density of the wood, but rather it's got to deal with the type of tree it comes from. Hardwood comes from dicots. Trees that are dicotyledonous, that have two cotyledons in the seed, and that would be something like this oak tree here. And you can see this is an absolutely gorgeous, massive type tree, and it produces a hardwood. Proper hardwoods can be used in furniture, and they can be used in a lot of different things. This looks like some sort of hickory. Again, it's a dicot, and it's going to produce a hardwood. We have softwood, and softwood comes from a gymnosperm. So we're not looking at a dicot, but rather we're looking at a gymnosperm. This particular tree was probably about 60 feet tall when I took this picture. I mean, it was absolutely monstrous, gorgeous ponderosa pine. This was growing in somebody's yard. It's an absolutely gorgeous Norway spruce. It looks like the type of thing that maybe they bought it one year as a Christmas tree and they planted it out in the yard, and it's just become this magnificent thing that's a 2-story house next to it. So this is about 40 feet tall, and it's a marvelous thing. You take the wood out of it, it's going to be what we call a type of pine. It's going to be a softwood because these are gymnosperms. So when we look at it, there's a difference between the concept of hardwood and concept of softwood. One of the other things we look at on trees and wood and secondary growth is we look at growth rings. If we look at this particular cut in here, the outermost part on the left is the bark. Underneath of the bark, we have where we've got the cambium layer, which is where you start to produce the bark and you start to produce the other stuff, and underneath of it, you produce the wood. And underneath that, you see what we call growth rings. And the growth rings are basically where the tree stopped growing at the end of a growing season. So you can see a growth ring here, and you can see a growth ring here, and you can see a growth ring here. And you go, wait a second, there's some big differences in the size in here. Yes, growth rings occur anytime you get a stoppage in growth. Now, from one ring to the next, from the first ring that's marked to the second ring that's marked, we had a rather large area of growth. From the second ring to the third ring, we had a very small area of growth, and that does not even look like a growth ring like the other ones. In this particular case, probably what happened is there was a drought or something else at that time of the year, and it came up looking like this. So we can see these growth rings, and when we look at wood, we often look at the growth rings because it gives us an indication of the age of the plant. It also gives us an indication of the health of the plant. Another material you find with plant stems is something called resin or latex. This is the outer part of the bark of a yellow pine, and yellow pine in the state of Florida was used to make turpentine and other materials. And basically anytime it gets damaged, it exudes this resin, and this resin is basically a material that is going to help it fight off infection so that it doesn't become colonized. The material comes off in a kind of gooey light color. As it spends time, it becomes aged and it becomes much darker. If you let it go long enough, it becomes very hard and can actually be used for a semi-precious stone. This particular stone is what we call amber, and this is tree sap. And in this particular case, you can see this insect got trapped on the inside of it. Tree sap came down, coated the insect, hardened up, several million years old, and that is preserved on the inside of that little piece of amber. And amber in that case is nothing more than resin from a tree. Latex is the same sort of scenario, but latex is a little bit different in format, and out of these trees we get latex, and we use the latex to make rubber. We also have on trees what we call lenticels, and this is a bark of a tree, and you can see these little oval shapes in here. These are lenticels, and concept is the lenticel actually allows for material to come in and gas exchange to occur through that particular part of the plant. So lenticels are very interesting on outer parts of plants, and we can see those as well.